So before I get started, thanks Seth for the introduction. Just a little bit about, what is Chief Innovation Officer? What does that really mean? So I've been in my role for 4 years now, and really what my role is all about is a CIO, so I have all the traditional CIO responsibilities. The role is created with the recognition that technology is disrupting higher ed, just as it's disrupting pretty much every other industry. And there was a need and a vacuum for a senior leader at the cabinet level who could shape what technology means in terms of higher education. So in addition to my technology responsibilities, I also have business level responsibilities for really the future of teaching and learning, what we're doing with online and how technology is not just driving pure online classes, but it's really permeating how and what we teach, how we do research, really everything about how technology is changing the business of how we conduct ourselves as institutions of higher education. And so with that, today I'm going to talk a little bit about how that future is changing and how we have to understand the context of this 21st century that we sit in right now and how that's affecting our institution in the future, as well as all of our constituents in terms of our students, our faculty, our staff, and alumni. So let's turn this on. Technology always works when it's on. There we go. Okay, so I'm going to start off with just a quick video.
The original Industrial Revolution was driven by the discovery that you could use images to do all kinds of interesting things.
And all the additional revolutions for electricity and computers and communications technology. We're now in the early stages of the fourth industrial revolution, which is bringing together digital, physical, and biological systems.
With the ability to visualize brain activity, for example, through a simple consumer-based EEG device, it gives us access to ourselves in ways that we never before thought possible. It unlocks the black box of this brain and enables us to really, truly be able to realize an identity that is aspirational.
I see the circular economy as something which fits very closely with mankind's goal to be innovative and creative and to always progress. We can use asset tracking, we can use IT, we can use 3D printing to enable this different economic model to recover materials, feed them back into the economy, and really to decouple growth from the resource constraints we have.
The reason we live in cities is not different today than it was 2,000 years ago. Even if we have got networks connecting us, we still don't have places where we meet in person. This means the place where we work, the place where we live are much closer to each other. In a city where we don't need to have big supply chains in order to produce things, where many things can be sourced locally, thanks to 3D printing and robotics. If we're able to do something to transform cities, to make them more efficient, then the impact can be huge.
Okay, so that introduces a construct I think is really important to frame where we are today, which is this idea of the fourth industrial revolution. You go back through history, there's been 3 previous revolutions, right? The first one, I think everyone knows from their history classes, which is the Industrial Revolution, right? Really drove people in the cities, completely changed our economy. And that was back in the late 1700s. But about 100 years later, you had the second Industrial Revolution, where you started to have mass production, the Model T, things like that, right? Again, most of us are familiar with that. The third industrial revolution, a lot of us lived through. It's why we're here today as a lot of IT professionals, right? Which is the electronic and IT system revolution that really drove back office automation, really started to drive a lot of the technology that's been really drove efficiency in our economy and really helped our economies grow. Today, we sit in this fourth industrial revolution, which is really combining technology with physical systems, right? And as you saw in that, it's not just about the technology piece, it's also about how technology enables humans to interact and really goes and allows a whole bunch of different efficiencies, business models, and continued growth in our economy and changing the world and how we live, how we work, and how we play. And so, just a little bit of what's changing. What's starting to drive some of this. So, a couple of key things. The first one is computing power. Right here's a graph of how computing power is expected to exponentially change over the next hundreds or so odd years. And what you can see is that at some point, hopefully by the time I'm dead, computers power to that past the power of human brain, right? There's lots of sci-fi movies and novels and shows that predict what will happen when we achieve that. We're already seeing, every year the computing power, according to Moore's law, is increasing and enabling things today that you couldn't do, even just 2 years ago with things like Alexa and artificial intelligence and whatnot. At the same time, we're having an explosion of devices and sensors, right? Everyone, I think, in this room is quite familiar with the Internet of Things. And you can just see, again, exponentially the number of connected devices from smart cars to smart signals to biomedical devices, just everything you can imagine becoming censored and measured. And all that data is being collected, right? And so we've seen the rise of enterprise data especially through that third industrial revolution. And now we start seeing the rise of social media data, which is highlighted in the press right now with the whole Cambridge Analytica and Facebook in terms of that data. But just wait until all those sensor data comes out. It's going to be interesting to see when you have the what that crisis will be. The Facebook crisis of the future with the sensor data, right? Because it's coming. There'll be a Cambridge Analytica that takes a look at all that data and starts doing a whole bunch of predictions that some people may or may not like, right? Will make the current crisis probably look a little bit humorous. But again, it's just an explosion of data. And then where does that data go? It's enabled. We can have an explosion of data because data storage is dropping dramatically, right? The cost of storing all that data continues to fall off the cliff. So you have all these factors that are coming together that really start to enable this fourth industrial revolution. And so what does the fourth industrial revolution really mean? And so this is the World Economic Forum. And they talk about it as a fusion, as I mentioned before, of technologies that blur the line between physical and biological spheres. Physical and digital and biological spheres, I'm sorry. So there's 5 key technology trends that I see that are really underpinning this fourth industrial revolution. The first one is we have this explosion of mobile connectivity in the cloud, right? We're always connected. And that's manifesting itself in that today you can go and, especially from an education standpoint, learn things without ever physically having to be present in a class, right? So we know the online classes, but these are 2 really interesting examples from my own personal experience with my children. So when my son went to go get a driver's license, he didn't go and take driver's ed like I did, being scared to death by the instructor yelling at me every time I drove incorrectly. He went and watched YouTube videos. We actually went and subscribed to a simulation that was very, very effective and really nice because it does put him into all sorts of dangerous situations without me having to be in the car with him, like driving at night, making left-hand turns. Very, very effective so that by the time he got out onto the street, he actually had a whole bunch of hours of simulated driving, again, right from his laptop. And then the other example here with Khan Academy, when I was taking the SAT years ago, again, I had to go take a class, go and sit there a couple hours a week. Well, now you can go in, do a self-assessment. Khan Academy will customize a training manual for you, go through a whole bunch of practice tests. And then this is very effective. My son's girlfriend actually went and did this and ended up getting a perfect score on her SAT. Pretty amazing that you can go do that completely for free. It's enabled because of this ubiquitous connectivity that we now exist in. Sensors, we talked about sensors. And they're going to be everywhere. And here's an example of a device that was just released a couple months ago from Medtronic. This is an always-on EKG, right? So you can, if you have any sort of heart condition or whatever, you can be constantly monitored in terms of your EKG. And because of that, right, you can go and detect issues much earlier than previously. I had to wait to go to a doctor's office and be checked out. 3D printers, right? We're starting to see the rise of 3D printers, and this starts to really fundamentally change the whole notion of mass production, right? most of our economic systems and business models are based upon scale of production, right? Well, now if you can deliver the same efficiencies in a micro production that you traditionally do in mass production and do it at a local scale, not have logistics costs, right? What does that change, right? That changes things. The first example there is an Indian high school student actually went and 3D printed a satellite and had it launched, and it's actually in orbit now. And then there's lots of examples. I think like every month you can see an example of some college kids who went and 3D printed a prosthetic. It's pretty commonplace now, which is sort of amazing that people are printing prosthetic hands and arms on a pretty regular basis. And then renewable energy, right? You need to have cheap, efficient energy to go and really fuel all of these devices, all this technology. We're really starting to see that, right? We're starting to see that. Examples, Tesla is driving solar panels, battery technology, both at the micro level for homes, but also battery technology for the grid, to make the grid renewable friendly. Go to Iceland, pretty much all of Iceland's energy is geothermal, very, very cheap, free wind farms. So we're starting to see that really a transition to more renewable energy that allows us to go and enable even more technology. And then finally, I think everyone is familiar with this last one, which is artificial intelligence. And we've really seen in these last 2 years or so this explosion, or just at the cusp of it, of artificial intelligence really starting to evade our everyday life. And I'm sure how many people have an Alexa or some sort of smart speaker in the home. Right? So about a third, maybe a little more than a third of us. And for those who have it, once you have it, it's sort of life-changing, right? You can't understand how you sort of live without it. We're seeing self-driving cars, and there's an example, a little self-promotion. At Georgia State, we've had a lot of success using AI to power chatbots, help our student experience and deal with our summer melt. And as I was putting this presentation together, it really became clear how sort of everyday this stuff is becoming, when just the normal Atlanta Journal-Constitution has their weekly tech section, and you just look at this page, this wasn't like something I created, this was a real paper from a couple months ago, and you've got things from, people, turning people into cyborgs, you've got smart shoes, you've got bottom left, teaching, sciences using technology, right? You've got all these things are really becoming commonplace, that it's being written about, not in, tech magazines, but just in the local papers. Okay, so what does this mean in terms of the future of work, the future of how we live and how we play? So it fundamentally changes work, right? So I've seen quotes like this is from the World Economic Forum, that 65% of children who are in primary school today will enter jobs that don't yet exist. Probably not surprising, a lot of us are in jobs that didn't exist 10 or 20 years ago. But that 65% is actually a lower number than many of the ones I've seen. So you can find predictions that could be as high as 80%. Right? So how do we prepare students for that? And not only will the job change, the total environment. And so this is a slide from a piece of research that Gartner did last year that talks about how do we work today and how we work 20 years from now. And a couple of things I'll highlight, I won't go through.
There might be more swag to collect in the future.
It's great, we have lots of discussion. So a couple things. Right now, teaming is a key behavioral competency. I'm sure it's on everyone's performance plan, right? How well do they team? In the future, it's more of a week working primary organizational model where teams come and go, right? As we start going into more of a freelance economy, much more agile driven. And so the teams are not permanent. You'll come into projects, get things done. And a lot of those teams, instead of managers putting them together and figuring out the work, they'll actually be algorithms and AI determining what are the skill sets needed for this given project. Where are those people with those skill sets? Putting them together, managing the project, and then also disbanding that so they can go and go do other things. The constant upskilling of those technologies, You see that there's this concern about technology displacing jobs today, but really what Gartner and a lot of folks see is that people plus technology is a killer combo, where that technology is helping people work more efficiently and really becoming their coworker, right? So yes, maybe we'll have some less managers, maybe not a bad thing, but there'll be plenty of other roles for folks to do that are going to drive more efficiency and actually be a lot more exciting. For those of us that have done middle management for a long time, I can speak for us that I would happily give up a lot of those administrative functions to a piece of AI, because it's the one thing that everyone always comes to when they become a manager saying, this is really what I have to go do, and it's not that much fun. And so really drive a lot more efficiency. Last thing is changes where people work, right? Because right now you work based upon where the jobs are. Well, now you can go and focus on where do I want to work, how do I want to work, what are the purpose is really much more important to me, because you have a lot more control of your work and what you're doing. So I mentioned a little bit about the freelance economy. And there's other stats that are projecting, same Gartner report, that well over half of employees in 10 years will be freelancers, right? So fundamentally, changing the sort of the traditional work contract when they're a freelancer in a gig economy. And as we go into that sort of freelancer economy, also another thing that I really hate as a manager is performance management changes, right? So we move from a annual sort of performance plan to constant and visible feedback, right? And so here's an example of someone who has, go into a dashboard and see how they're doing. And this already exists. There's a startup out of Silicon Valley called Gigster that is a basically an online software job shop, and they pull together teams to go and deliver software projects for corporate customers. And actually their secret sauce that they created is this tool called Karma, which is constantly rating. We got a Karma score for each of the employees that's rating them based upon their skills, based on their feedback of their coworkers, based on feedback of their customers. They do some initial testing to go and build the initial Karma score, but that's how they go and manage their employees, and it's completely transparent, completely visible. Very, very different than waiting to that end of the year meeting with your manager to say, well, how did I do? Right? It's on a daily basis. It's very much like a gamification type score. So that's great. How are we going to play? Right? Some of this we're seeing already. In the explosion of virtual reality and gaming. At Georgia State, we just started our first student gaming team. We're part of the first collegiate gaming athletics, it is athletics conference that's been created. We're starting to see that become very, very prevalent and really be actually the future of athletics and sports, at least potentially as big as some of the major sports today. It's pretty interesting when you meet with companies in this area and you see their presentations, see the professional tournaments that are going on, especially in Europe, how big they are. And you look at the list of sponsors. Once you take out Intel, all the sponsors are the same ones sponsoring football and baseball. It's Anheuser-Busch, Red Bull, Coca-Cola, right? Very, very easy to see that, hey, if for whatever reason, this next generation doesn't like physical sports, those advertisers will just move those dollars right across the line into electronic gaming. And then we're seeing it in fitness and training. Anyone do Orange Theory here? The whole premise is that you're constantly connected and you got a board that's watching your physical heartbeats and calories and getting that feedback immediately during the workout. Got Peloton, a startup that's delivering cycling classes and now actually running with a treadmill, first with a cycle, a bike, where it's all streaming, right? You're actually streamed into a live class somewhere else. And so now you don't have to go to a gym to work out. You can just go into your basement or to your guest room, get onto your treadmill, get onto your cycle, and then right there through the screen, you're part of a workout class. Very much changing how we live, just everyday lives, everyday, sort of mundane tasks. This first one is an example from Amazon Look, right? So for those of you who aren't familiar with that, this is a camera that you're supposed to put in your closet, and we'll go and you see the person here stands in front of it, and it will tell you what in your closet will match with what you're wearing. This is like the electronic version of Grandma for those of us who grew up in the 70s, 80s, right? The other thing it will do, of course, it's driven by Amazon, it will recommend maybe a shirt that you don't own that you could go buy that would match what's in your closet, and creates an inventory of all of that. Really, really amazing. The other example is another startup, and these are dumb devices, right? These basically, both these examples are dumb cameras that now with the use of artificial intelligence creates whole new usage models. So this is another camera. This is a camera for the home called Lighthouse, a startup from some former Google employees. It uses artificial intelligence to learn about your home and send you alerts based upon that. And so as an example, it can tell if you can say and use a natural language query it. So you can query your camera, did the kids feed the dog, right? And it'll know because it's watching your kitchen, and it'll know if your kids have fed the dog, or hey, if the kids shut the door, so you can see the door, right? Things like this, and they claim, and now we know this is probably true because as AI gets smarter, there's more and more that you'll be able to ask this camera about. So again, back to all that data that the sensors are creating, this is the type of stuff that, depending on how it's used, could be creepy or really valuable, right? So I laugh with the Cambridge Analytica, but it's really just the tip of the iceberg. Another really interesting example in terms of this notion of really changing mass production into micro production. So if you go and look at, there's actually a researcher and a team at MIT, the digital labs, it's sort of funny because our media labs, this really has nothing to do with media, that's doing a whole bunch of work on the future of food production, right? Because if you go look at how food is produced around the globe, it's all driven by mass production, especially over taste, right? So a lot of the vegetables and produce that we produce were grown many times months, if not a year, before you actually eat it as a consumer. And it's bred to allow it to make that time period without spoiling. And so the taste is sort of secondary, if not tertiary, in terms of the factors. What they're doing is creating a food computer. It looks like a sort of big 3D printer. You see the picture where with a whole bunch of sensors and intelligence and automation that automates the watering and the nutrients and all that fun stuff, that you could go and produce basically any produce, any vegetable on a micro scale, make it taste way better than if it was produced in a traditional farm and traditional production process. And that can be done anywhere. It can be done in the desert, it can be done wherever you need that, right? Just at a sort of on-demand local use, and really change some of the problems that we have in terms of our production of fresh fruits and vegetables. Really, really interesting. This is all, actually, if anyone's interested, this is online. It's called the Food Computer. You can actually go download all the schematics. You can go build it for a couple $100. They tell you what to order on Amazon. And one of the things they want to do by doing that is create a database of basic formulas for basically every fruit and vegetable around the world. And so you can go produce, for example, they produced a tomato that hasn't been grown in 100 years. That's specifically the best tomato to make tomato sauce. And for a variety of reasons, it's really not grown anymore. But they were able to go reproduce it, grow it, and make tomato sauce out of it. So it was excellent. So pretty interesting. Cities are changing, right? This one of the things that we're talking about right now at Georgia State University is we are not going to go build any more parking garages. We actually believe that in 10 years we can repurpose our parking garages because we won't need them anymore because of self-driving cars, right? Because people won't necessarily own cars. Maybe it's a subscription service. Right? For me personally, I only really drive my car 2 hours a day. Unfortunately, it's an hour each way back and forth to work. But if I could go and just pay a monthly fee that gives me a car just for that period of time with maybe some extra hours for when I need it for a meeting here or there, I gladly don't have a car sitting in my garage all the time, right? And so we see that coming, and cities are starting to plan for that, right? What does that really mean for the design of cities? So then we got to take it back to, all right, so that's great. What does it mean in terms of the institution, the university? And so what I sort of posit is that we really need to be thinking about how do we create the digital university? It's really a digital enabled university. This isn't a we're going all online, we're getting rid of all of our physical plan. It's really a university that's digitally enabled for this new fourth industrial revolution. There's 6 elements of that digital university. There's a lot of focus on how we teach, and a lot of people talk about that, but equally important is what we teach. I'll talk more about that, but really embedding those digital skills in every student, regardless if they're an engineering or technology or STEM major. We have to be in any time, anywhere university. We have to enable our students, our staff, and our faculty to really interact with us anytime, any place. Collaboration and communication is a critical component of that. Delivering a terrific student journey, leveraging technology to deliver that student journey at scale, very customized. And then finally, unfortunately, one of the major jokes about this throughout the presentation, but once we digitize the major functions of a university, of our society, cybersecurity becomes critical. And for those of us living in Atlanta right now, or the city of Atlanta that was hacked now about 3 weeks ago, and they still haven't got all their systems up. A great time if you want to go work out in Atlanta because you can get into any of the recreation centers for free because they can't check you in. Bad time to try to go and close on a house because the water company's billing system's down. So a lot of closings are being held off because they can't confirm that there's an outstanding water bill in the house. Right? Pretty incredible. And that can take down a major city for so long. And so we have to be concerned about that as we deliver these great things, these great experiences for our students and our stakeholders. How do we make sure that they're protected and we don't have our own Cambridge Analytica? So first, what we teach. And I think if nothing else, this is the most critical thing that we have to really be focused on. And it's imperative for us as technology leaders within the university really to drive this because we're really the ones really at the forefront of it and really understand it better than anyone else, which is driving digital literacy into our curriculum. And we've been doing this now for the last couple of years at Georgia State University. It's actually the #1 goal of our business school. You can see the goal there, which is to empower students to be able to seize the opportunities of the technology revolution. And so if we want to prepare our students to be ready for those 65% of jobs that don't exist, we have to make sure they've got the technical skills and the digital dexterity to learn new skills and learn new tools and be really good customers of it, consumers of technology, regardless of their major. And so we've been driving, embedding digital literacy, as I mentioned, in the core curriculum. So, for example, our English class today, our freshman English class, which is about English composition, isn't just about writing pen on paper. It's how do I design a web page? How do I write 3-dimensionally, 4-dimensionally for writing online? How do I actually understand some basic scripts? Because I don't necessarily have to write code, but if I'm going to be writing in the future, so much of writing is digital. I have to have those skills. History is starting to use visualization technology to go and look at history in a whole new way, right? So using maps and other types of visualization tools to teach history. And now, as we've been doing this for a couple of years, we actually have created a moonshot committee that's looking at a more fundamental change of our core curriculum. And probably a big piece of that will be embedding more and more experiential projects into the curriculum on top of that core digital literacy, because so much of these skills really need to be tried out. And I know that's very typical in engineering schools, but in a more of a non-engineering school, such as Georgia State, we haven't had those sort of capstone projects. And most of those will be geared around these digital problems that we're facing. So how we teach, right? We're driving a lot more technology into the classroom, using more virtual reality. We just launched our first makerspace this year, and after we launch this one, we now have 2 more around the campus that are being put in place. And again, these are digital makerspaces for non-engineering schools. right? And it's teaching space. We have English classes coming in, so you can go in and use the virtual reality tools, the sewing machines. Actually, one of the biggest things that the students will be using is sewing. As we've gone back to this maker sort of ethos, students are wanting to learn how to sew. And they're using these making tools and techniques again into their classes and helping them go teach those digital literacy skills. So we have to have a network that is extremely robust to go support this. I need a better graphic, I apologize. But I know ServiceNow is here. One of the things that we've been really focused on at Georgia State University is building our platform that allows us to really be able to automate as much as possible, be able to go and scale and respond to any challenges we have on the network. Quite similar to the team here at Auburn, our enterprise infrastructure team, they are amazing firefighters, right? When something happens, they mobilize quickly within an hour to a couple hours, they can go and solve it. But in the future, with ServiceNow, with NSX and virtualizing the whole network, with other platform tools we're putting in place, we really want to go and automate things. So if we see, let's say, a road sensor come onto the network with some of our cybersecurity tools and network access control, we can see that immediately, shut it down, so turn off that device, put it in a little virtualized bubble, and then automatically send a ticket to the appropriate folks via ServiceNow, right? And that happens in a couple of seconds versus people having to go and see that happen and go and figure it out over a couple hours and do the same thing, right? It's those type of usage models and techniques that we really need to put in place to enable us to support all of the activity that's going to be happening on our network and do it in a stable way. I don't know about you guys, before I go off that, our worst users are our computer science department. If the computer science department would just probably ask before they do things, we'd probably cut down on half of our network values. So any techniques on that would be appreciated. And then the student journey. We've got a lot of press at Georgia State for our work with predictive analytics. We've been doing that for a while. But we're continuing to go and build out learning analytics at the classroom level. And a lot of that is driven by adaptive learning. So we right now are in the process of taking our 5 biggest classes in our freshman year. So micro and macroeconomics, biology, and a couple others, putting them in an adaptive platform, getting that data, and really, again, allowing us to customize that learning for the students, but also getting that data back to the advisors, back to our professors, so that we can understand why a student may be tracking to not perform well in a class before they actually get a C. Because right now, the way our predictive analytics works is we know, as an example, you get a C in your freshman algebra class, and you're a declared STEM major like physics, your probability of graduating with a degree in physics is very low. So you get a C in mathematics, you go and have to meet with your advisor, and you're going to have to either take a remedial math class or change your major, right? And that's worked really well. What we want to do is within that first 3 weeks of that math class, because it's adaptive, be able to go and we have the right learning analytics in place, go and have that red flag that goes to the professor and your advisor, and they can sit down in that 3-week period to find out what is going on that they're not understanding and get them on track to a B so they don't have to go and have that conversation after the class was taken. Other piece that we're working on with the student journey is going and building out an entire engagement platform based upon Salesforce, where we can go and take all of the data that exists throughout the institution, right? We have a lot of systems of record that each department has, from our enrollment to housing, all the way to alumni affairs, and none of that data is shared, right? And so we don't necessarily want to go replace those ERP systems or those CRM systems. We want to have one pane of glass where if a student calls in or has an issue, it's housing, we can go see what's going on in other parts of their student experience, because they may be related, right? And by sharing that data, if we see, this happened last summer when we weren't doing this, if we see more people going and putting deposit checks down than we've anticipated in the past, but we're not going and mapping that up. So the number of placements we have for houses, right? And all of a sudden we allowed more students to come into housing than we expected because it trended, more people arrived on campus than we expected, right? Usually our historical drop rates of people that didn't show up for their housing changed, and we could have correlated that because we would have seen more people not only seeing the housing system, their housing deposits, but seeing them paying their tuition bills. Simple things like that. In addition, we can go and make sure that the records are clean. There was a Chronicle Higher Ed article a couple of weeks ago that was very complimentary to Georgia State, but the example that they gave at the beginning of this article really made me cringe because it was talking about our chatbot that we use for summer melts and how that's really helped our students arrive on campus with a summer melt. For those you don't know, is you always have students, especially if you have underrepresented students, who have done everything right and look like they're going to show up on campus, but they don't. And so trying to make sure that, why the student, and when they don't show up on campus, they don't show up anywhere. So we use chatbots to be able to go and enable quick questions. We had 20,000 plus interactions last year with it. And one of the examples in this article was a student that was getting ready to come for their fall semester, for their first semester, and they hadn't received one of their scholarships, and they weren't sure what was going on, and they needed that $4,000 to pay the bill. They didn't get their scholarship, they're not showing up. So through the chatbot, they're able to go in and triage it, get an advisor, find out that for whatever reason, their social security number was entered incorrectly in the financial aid system. Even though it was correct in manner and everything else, it was incorrect there, it wasn't showing up on their birth certificate. So that was fixed. If we had our one engagement platform and all that data in one system of record, then I can use AI bots to constantly crawl through that and say, hey, why do we have these two records, same student name, same address, different social security numbers, right? Add that to a customer representative, a student representative, to go and change that, right? That is actually my view is like, oh, it's a bad example because we should never got that far, right? And that's the type of stuff we want to go do with the student journey. And then finally, real quickly, you mentioned earlier, as research universities, this posits a whole bunch of research questions beyond just technology questions. So very, very quickly, just from an economic standpoint, what does this freelance economy mean in terms of healthcare, insurance, retirement savings? What does the micro versus macro production mean in terms of our economy and the way that we structure manufacturing? From a legal standpoint, lots of legal issues, right? We're starting to see the legal issues with self-driving cars, right? With the Uber self-driving car getting involved in a fatal accident, right? Who's at fault? Another one that really hasn't hit the radar screen, but will have to be discussed at some point, is if we get to a world where it's really all self-driving cars, and we don't really need driver's licenses. Driver's licenses are a default identification. So we need to have a national identification, right? These are major issues that need to be discussed, figured out. Healthcare. Can and should humans be augmented to improve performance beyond the norm? Right? There's an example at Jim Swimmer Institution and the trade school up the road from me that they've developed a robotic arm for a drummer. And when they did that, they gave him 2 drumming sticks on that hand, so he can now drum with free drumsticks, and can drum at a frequency, a hertz frequency, faster than any human. So now he actually can perform and do things that no other human can do because of that technology augmentation. And then ethics, right? Lots of ethics questions. And again, anyone that watches sci-fi, Altered Carbon, seen that, right? Lots of ethics questions posed by, technology and the have and have-nots, right? So if I can afford to go and have higher performance by cutting off my hand and replacing it with a robotic arm, is that okay, right? Is it ethical? So a lot of issues that will have to be determined. And with that, I think I'm right at time, but if I have maybe a couple questions I can answer. Yeah.
Think about the American Revolution. It was fought because the legal system didn't address the social structure at the time. It's getting to the point where the technology right now, you notice the revolutions are getting closer together on your program. Even in the case of Facebook and Cambridge Analytica, the legislative branch is not able to address technological changes in a matter of time, deal with them appropriately. And you see a legal revolution in the future because of that?
Yeah, what I say that the quick answer is long, is that the revolution will probably be outside the legal system, and it's going to be driven individually. Probably the biggest thing you see there is blockchain, right? Where blockchain will enable individuals to own their data and their privacy, and then give access to it. So, for example, a good example of blockchain is in higher education, right? Today, the way credentials and records are given is you have to call the bursar's office, right? Get a copy of it. In many cases, like I have to pay Yale $25 for a degree that I spent way more than $25 for. I don't understand that. I get a copy of my records, but they own it, right? In the blockchain world, I own that. I actually can go and add other credentials beyond just what I learned in that 4 or 5 years at college. And if someone wants access to it, I can go give a key to unlock that. And as a university, I also have a key to go validate that it is a true credential. So I see that type of blockchain technology, I think, be used in healthcare, lots of areas where it flips the power to the individual, and I think that's going to happen sort of independent of the government. Yeah.
Just touching on the computer science use case that you brought up, and just curious about Georgia State University and its networking. Are you all exploring SDN in any way on campus as a way to? Yeah,
so we actually have a huge project that we're getting ready, almost finalizing, where we virtualize the entire network using VMware's NSX. And so
the entire campus network?
Entire campus network.
So how, I gotta ask, what's the licensing on that? I mean, I'm curious because NSX, as I understand it, is cheap on the VMware fabric. So how does that, are you controlling physical switches with that NSX product, or I'm just kind of curious about that?
I can connect you up with my enterprise team to go through it. But we have it across, and from not sure all the license deal with big deal, but at a high level, in terms of the way we're affording it, is it's allowing us to go and actually commoditize all the switches and not have to go change them out as often, and also allowing us, because they're commoditized, to self-maintain. So I'm getting rid of my maintenance contracts and saying, you know what, I'll just go buy a bunch of generic switches, and if they break, I'll swap them out, right? Versus paying, Cisco and Extreme, a couple $100,000 a year for a maintenance contract. And so, but it is a big investment. And I mean, even with doing that, we've had to use one-time money to go and get the project through initially. But we see a lot of benefits. It also allows us not to go and continue to hire as many people, right? Another metric that we're looking at is the number of people managing nodes, right? Because now it's sort of generic nodes. We want to continue to scale that number. We have to scale that number, right? Because the nodes are increasing, but we can't afford to increase our people at the same rate.
I think that's all the time we have. Let's hear it for Phil B.